Did you know that every number floats in a sea of zeros? Sounds strange? Let me show you what I mean. Let's begin with a very easy number like 68. You'll know that the 6 is in the tens column, so we can write that over the top. And the 8 is in the units column. Now, while I'm at it, I'll mark the hundreds and the thousands columns too. I can now ask the question, how many hundreds are there? And the answer, of course, is none, so I'll put a 0 in that place. Now I can ask, how many thousands are there? And the answer again is none, so I'll put another 0 in there. In fact, I could keep asking this question forever and ever, and the answer will always be none, so there's a whole string of zeros going on forever to the left. And I'm going to show that by putting in 3 dots. That indicates that this row of zeros never ends. Now let's look at the right-hand side of the number. The figure 8 in the units column is the last digit in the whole number part, and then comes the decimal point, of course. The decimal point is always in this position. It never moves. And the reason it never moves is because its job is to separate the whole number part from the decimal part. Now, let me mark in the tenths, hundredths, and thousandths columns. Again, I ask, how many tenths are there? And again, the answer is none. So we put a 0 in this place. And the same for the hundredths, and the thousandths, and so on forever and ever. So I'll use the 3 dots again to indicate that the zeros never stop. So perhaps you can now see what I mean when I say that every number floats in a sea of zeros. The number 68 is really 0.0000068.00000 going on forever and ever and ever. Of course, we never say that in normal life. People would think we were absolutely mad. We just say 68 or perhaps 68.00 if you wanted a decimal place or two. So what's the point of doing all this? Well, that's where the fun begins. Suppose we want to multiply the number 68 by 10. I'm sure you know by now that when you multiply by 10, every digit moves one place to the left. So let's do that. The 6 in the tens column moves into the hundreds column. The 8 in the units column moves into the tens column. And all the zeros to the left move one place left too. Now remember that the decimal point never moves, so let me put that in now. Now most people say that there's a space in the units column, so they're going to put a 0 in there, almost as if they couldn't think of anything else to do. But what we need to remember is that all the digits move to the left, including all the zeros. Every one of those millions and billions and zillions of zeros moves to the left one place too. So the one just to the right of the decimal point moves one place into the units column. You see, there never was a space. That 0 was there all the time, just waiting to jump across the decimal point. Now we can put in all the other zeros because they all move to the left one place too. And again, I'm going to use 3 dots to show that these go on forever and ever to the right. When reading this answer, of course, we would just say that 68 multiplied by 10 is 680. We wouldn't, of course, bother to say all those other zeros, but don't forget that they are there all the time. You should be able to see now what happens when we multiply a number by 100 or 1,000. As an example, let's multiply 56.8 by 1,000. Now, I'm sure that you know that when we multiply by 1,000, every digit moves 3 places to the left. It's 1 place when we multiply by 10, 2 places for multiplying by 100, and 3 places for multiplying by 1,000, if you're not quite sure. So here we have 56.8, and we now put in the zeros that we've been talking about before. All we need to do is to move every digit 3 places, so that the 5 in the tens column moves into the 10,000s. The 6 moves into the thousands, and the 8 moves into the hundreds. Now, what about those two spaces? Well, we know now that really there are no spaces, because the first 0 after the 8 moves into the tens, and the second 0 moves into the units. And we can now show all the other zeros as we did before. So now we can see that 56.8 multiplied by 1,000 is 56,800. Now, what could be easier than that? So far we have used the extra zeros to the right of the number to help us multiply by 10, 100 or 1,000, but we haven't yet used the zeros to the left of the number. Can you see when they might be useful? Yes, it's when we divide by 10, 100 or 1,000. So let's finish with the division example. Let's say we want to divide 2.57 by 100. If we move the digits to the left when we multiply, we must move them to the right when we divide, because the number is getting smaller. So in our sum we need to move each digit to the right 2 places. So let's put in the zeros as before. Now we can move each digit to the right 2 places, and to save time, let's do it all in one go this time. And you may think we have a space between the decimal point and the 2 digit, but now we know what happens. The first 0 before the 2 moves 2 places to the right as well, and moves into that space. And then we can put in the other zeros. Of course, we don't say all those zeros, we would just write 2.57 divided by 100 is 0.0257. Can you see now how it helps to think of every number as floating in a sea of zeros? When you multiply or divide by 10, 100 or 1,000, or even bigger numbers such as 10,000, 100,000 or 1,000,000, the zeros we need are already there as part of the number, waiting to be moved to fill in the spaces we make by shifting left or right. We just don't need to mention them all the time. And so you may be asking yourself if you need to write down all these extra zeros when you want to do something simple, like multiplying a number by 10. Well, of course not. Just write down the digits you need for your sum, but don't forget, those zeros are always there, waiting to move into the right places, just like all the other digits. Of course, if you had a headache in a maths lesson one day and your teacher gave you a sum like 68 times 10 to work out, when she asked you why you were taking so long, you could always say that moving the 6 and the 8 was easy. What took the time was moving all those zillions of zeros along one place too. I wonder what she'd say.